So welcome to KPU CloudLab for the electron charge to mass ratio experiment. For this experiment, we've got an apparatus that has a set of coiled copper wires that you can send current through. And I will show you how to do that in a minute, but that's going to create a magnetic field inside of those circular wires. To change the coil current, we can use the slider just down here, and you can set it anywhere from about 0 amps to about 2 amps. The other thing you can change is the beam voltage, so there's going to be electron beam inside the tube here, and you can change the beam voltage with the slider below. For the cameras, you'll see that main camera 1 has the exterior of the device, and that's what we're seeing right now. If you click on preset 2 under main camera 1, then you'll see the coil current supply. So this is the power supply that creates the current. Here is where you read the current under setting 3, and that's going to be in amperes. And note that you're going to be measuring along the top of this scale so that your current is in amperes. So it goes up to 5 amperes. It's set up that way. Preset 4 shows the beam voltage supply. Preset 5 shows the reading for the beam voltage. And for this one, it's set up to go up to 300 volts. So we're going to read off the bottom of this scale, just keeping in mind that each of these is 300. So 100, 200, 300. Before we're able to change the current and voltage, you need to turn on the heater control. And this just heats up the cathode, and electrons will be able to be boiled off of that cathode and accelerated, which is what we're going to need to create our beam. This takes about 1.5 minutes, so you can start that right away. Okay, the objective of this lab is to determine how the voltage in the electrons is related to the coil current and how that's related to the electron beam radius, which we need to look up next, and then we'll be determining the E/M ratio with some measurements. Once you've given enough time for the heater control to heat up the apparatus, then let's look at main camera 2, preset 1, and this shows a nice image of the bulb itself. Now the beam is going to appear inside there, and we're going to want to measure the diameter. To get a close-up view of that, we want to select the interior close-up preset 2. But before I do that, I'm just going to accelerate the voltage using the slider at the bottom, and now you can see a nice bright beam. It's coming straight down from the cathode to the anode and hitting the glass, which we don't really want to do for very long. It's not good for the bulb. So to prevent that, I'm just going to turn up my current in the Helmholtz coils, and that will bend that beam into a circle. Next, we want to measure the diameter of that beam. So I'm going to get a close-up view of the scale. Now this isn't very easy to read, but that's because it's a glass ruler inside of a glass bulb filled with low pressure helium. As we change the beam diameter, you can measure the diameter here. What this says here is 8 centimeters, and it goes up past 9 and up to about 10, and you can't go any further than that because that's as big as the bulb is. So when you're ready to measure it, you can just try to estimate that reading according to those values that you see here. Okay, so let's say I want to measure the diameter here. This is going to be about 9.6 or whatever you think it is. Now this is in centimeters, and make sure you estimate uncertainty for that. That realistically accounts for the uncertainty that exists for this measurement. So I'm going to go back out and look at that whole beam. It's a big circle, so that's a diameter we're measuring. You're going to want to calculate the radius for your calculations, so make sure you divide that diameter by 2. Also, when you divide the diameter by 2, you have to divide the uncertainty by 2, so don't forget that. When you're done, then you want to turn off the power supplies. To do that, we just bring them down to 0, and you can see the active lights go out as you do that. So I got rid of my beam voltage power, my coil current, and finally I want to turn the heater off. And then it'll be ready for the next person. You can chat in the chat box of Mikogo. Just mention that you're done, and the operator will release control from you and give it to somebody else.